Okay, before we get on those examples, first thing I want to point out is I put this list of derivative rules, right? So all these antiderivatives, our focus is that we're thinking about antiderivatives through the lens of derivatives. We don't want to learn a whole bunch of new stuff. We just want to know derivatives well enough that we can think kind of in reverse. Okay? So here I put up this list of derivative rules from Calc 1 course. So you got all your basic ones here, the 6 trig functions, the 6 inverse trig functions, and then to the right of each of those is their derivative, and then just the general rules down here, chain rule, product rule, quotient rule, constant multiple. So that is posted here in the homework. So right now it's below today, the homework that was due today. So I'll kind of keep moving it up towards the top so you can find it somewhere. So it's this list of derivative rules. That's for your reference. Okay, next thing is that border elevation problem. Like the meteor problem, I'll post a full solution. So that will be important for you to make sure you get your questions answered either by looking at that solution or talking to one of us. Okay? I'm not going to spend time in class. But these worksheets that have to do with the fundamental theorem are critically important because they're testing your understanding and knowledge of the fundamental theorem and the meaning of integral and how we use all that stuff for real world stuff. So those worksheets are really important. Make sure you're understanding those questions and those. All right. So does anybody remember or have what? Did we decide on 23 and 25? Is that what we decided? And anyone remember or have that handy? What? 23 was what?
1 over the square root of 4 minus x squared dx.
1 over the square root of?
4 minus x squared.
Okay.
And it's in the
And what was 25?
X over the square root of 25 minus x squared dx.
Like this? Do I got them both right?
23 is a definite interval from 0 to 1.
Oh, definite. Okay.
25 from 0 to 3.
Now do I have them? Okay, so when we're going to start learning these different techniques for antiderivatives, when we have these more complicated rate functions, undoing the chain rule is always going to be the first thing you look for because it's the most common type of more complex antiderivative. Well, so I should say, before you look for undoing the chain rule, just look for it to be a basic rule. Okay, so it's just it doesn't really require technique. It's just a derivative that we learned without any really technique to it. So you look for that first. Now, if it's something more complicated and it's not just a straightforward antiderivative, then the first thing you always want to look for is undoing the chain rule. Okay? So this first one, is it undoing the chain rule? So do we have something like g prime f of x times f prime of x? Is that what we have here? Someone's saying yes. Everyone agree? So we could rewrite this as 4 minus x squared to the, if we wanted to, negative 1/2. Does that have this form of g prime f of x times f prime of x?
Can we just use the rule that that is going to be, it's very similar to the derivative of arc sine?
Okay, yes, but that wasn't my question. Yes, you're right. That's where we're going. But is this undoing the chain rule? What would need to be different about this in order for it to be undoing the chain rule? So how could you make one small adjustment to this so that it would be undoing the chain rule? What else would you need in here? Wouldn't you need like x, right? Why? Because we're looking for this form here, where you use this composite function, and you have some other term that's what? Like essentially the derivative of the interior function. So here's this interior function. What's its derivative? Negative 2x, which is essentially just a linear term, x to the first. We don't have that x to the first. So it does not match this form, but if there was an x there, it would. So that's like this problem. Do you see this? This does match undoing the chain rule because we have this x, which is essentially the derivative of that interior function. Do you see it? So this one, yes, undoing the chain rule. This one, no, it's not. So he's onto something in the back there. This looks a lot like, it looks a lot like a derivative of arc sine. But what's the problem? How is it not arc sine? Arc sine is 1 over the square root of 1. It's got to be a 1, right? So if this is anything but a 1, it's not. It can't be the derivative of arc sine. So can we kind of manipulate this or tinker with it so we can get a 1 there? All right, so here's what we're going to do. We could divide this by 4, and then we'd also be dividing that by 4. But in essence, by dividing by 4 under the square root, what did we really divide the denominator by? 2, right? We divided by the square root of 4. By putting that 4 underneath the square root, we're really dividing both these terms by the square root of 4. So to balance it out, we need to divide the numerator by the square root of 4. So now, this has the same value as what we started with. So do you see what happened? So we needed to get a 1. It needs to be 1 minus something squared for it to be the derivative of arc sine. So I divided the denominator by the square root of 4. And by doing that, it makes that a 1. And makes that x squared over 4 under the radical. And so if I divide the denominator by the square root of 4, I've also got to divide the numerator by the square root of 4, which is 2. So I get 1/2 1 minus x squared minus 4. So now can we do arc sine?
Yes.
Yeah.
So what is this? This term right here is essentially x over 2 quantity squared. So what is this the arc sine of?
X over 2.
Arc sine of x over 2. And we can say that's first attempt. Because there's some other, this is going to be chain rule now. So what's the derivative of that? So we'll take the derivative. Be 1 over the square root of 1 minus that thing squared. And then times, by the chain rule, times the derivative of the interior function, which is?
1/2.
And so now we look at that and we say, is that exactly the same function that we started with? It is. Because we have the times 1/2, and here it is, look right there, times 1/2. That means that this is our antiderivative, so then we're going to evaluate that from 0 to 1. Okay, did I lose you? Ask me if I lost you. So arc sine of 1/2 minus arc sine of 0. And what is arc sine of 1/2? Is that pi over 6? Arc sine of 1/2 is pi over 6. Arc sine of 0 is 0. So if I finish it, we get pi over 6. Okay, if I lost you, please ask. Are we good? Okay, we won't grade that one. That's kind of a tricky technique. We didn't really talk about it, but so this is just the idea of, he's right. It kind of looks like arc sine. We got to make it look exactly like arc sine. And that means getting a 1 there. Question up here.
Yes. Will the arc sine equations usually have x squared over something? Like, because you just got rid of the 2, the squared. And is that because of the square root right there, or?
What now?
It was originally x squared over 4.
Right.
It was x over 2 squared.
Yeah, because the arc sine would be 1 over square root of 1 minus something squared, an argument squared.
Okay.
So that's why we're thinking about chain rule, right? We're thinking about chain rule. You're going to just take 1 over 1 minus that thing squared, some function of x squared, then times the derivative of that thing. Yeah, so if it's not just x squared, then it has to be still a whole thing, something squared. Other questions? Okay, so then for this one, it is indeed, this last one is indeed the undoing the chain rule. Because it is did I get it right? Was it x over the square root of 25 minus x squared? Okay, yeah, so this one is undoing the chain rule. It's not, it may also look a little bit like arc sine, but because of that x, it's not. But we see that we have this is essentially the derivative of what's inside there. So so this is our g prime f. Remember our first attempt is going to be g of f. So what would our g of f be? First attempt is going to be 25 minus x squared to the positive 1/2, right? Antiderivative, so we're doing the antiderivative of the exterior function g prime, leaving the inside as it is. But then we know there'll be a 2 there for the 1/2. So this could be our first attempt. Take the derivative. And we get 25 minus x squared to the 1/2 times negative 2x. Is this exactly what we had to start with? No, we have this extra negative 2. So how do we make a second attempt so that we wouldn't have that negative 2? You're not going to divide by negative 1/2.
Or multiply by negative 1.
Yeah. So we want to divide by negative 2. We divide our second attempt, or divide the first attempt by negative 2. Then when we take the derivative of that negative 2 won't be there. So it'd be 2, say, over negative 2, 25 minus x squared to the 1/2. Derivative now will be, it'll be right. It'll be 25 minus x squared to the 1/2 times x. Check. So then that will just be negative 1, and we're going to go from 0 to 3. So that total change of this quantity as x changes from 0 to 3 at the rate x times radical 25 minus x squared to the minus 1/2. This also will compute that total amount of change. It's the quantity function evaluated at 3. Final value of the quantity minus initial value of the quantity. So keep going. Plug in 3, plug in 0, subtract. Watch your sign. Be careful on the negative. Okay. Questions on, yes?
When the exam, would you want us to check all the way? Like every single attempt, check? Or show the solution, not check?
You don't, so the goal is that we get this correct antiderivative. So this structure, I don't care that you're checking. I'm just trying to give you a structure that the goal is that we get the right antiderivative. So any way that you can get that is fine. So I'm not looking at this as something I'm not trying to teach you this. I'm not trying to teach you to do this procedure. I'm trying to teach you to look at these rate functions that are undoing the chain rule and as efficiently as possible come up with the antiderivative. This structure kind of aids in that at the beginning. So following the structure can aid in that at the beginning. But the goal is when you do lots and lots and lots of these, you just start to see that this is the result of the chain rule. And we're always asking the question, what function would have that as its derivative? That's the question we're asking. What function would have that as its derivative? Questions? All good? All right, so let's move on to the next technique. Which is undoing the product rule. Undoing the product rule. So let's recall what the product rule says. It says that if you have the product of functions and you want to take the derivative, it's what? The first times the derivative of the second plus the second times the derivative of the first. So if we thought about antiderivative here, so I could maintain equality by taking antiderivative of every term, right? So the antiderivative of fg prime is just fg, and then I'd have antiderivative of fg prime and antiderivative of gf prime. Okay, so when we talk about undoing the product rule, it's not that we'll be given this a whole sum of two terms like this, and we're trying to come up with what fg is. Okay, what will happen is our given integral will be like one of the two terms that you got when you did the product rule. So given integral would be, say it's this one, fg prime, and we want the antiderivative, but the basic rules, and then we want to always ask, is it undoing the chain rule? And if it's not, then this might be our next line of defense. Is this like the integral of one of the terms in a product rule problem? Okay, and so what happens is this one would be an easier, more straightforward antiderivative. So if we're checking to see if it's undoing the product rule, we're going to check this other, like the other term that would be from the product rule. If that one's straightforward and easy, then we're really solving for the given one indirectly. What would our given integral be equal to then? So to find the value of this integral, we wouldn't really be doing the antiderivative of it. Instead, we could solve for it, right? What would that integral that I've highlighted red be equal to?
Times g minus the easier one.
Right. So then we would just need to figure out what f times g is, and then subtract the easier one, and that's the one we'll actually solve. And that whole expression will be the antiderivative that we were asked to find in the first place. Does that make sense? So here's the strategy. We're going to think of our given integral as one of the terms of the product rule. We're going to figure out what f and g are. And then we're going to compute the product of f and g, and we're going to evaluate the antiderivative of g f prime. And then we're going to solve for the one that we were asked to do indirectly. So we never really do the antiderivative of the one we were given, but we can kind of solve for it indirectly by doing fg minus this easier one. Okay, so let's see. So there's that strategy again. So here's an example. Integral of 4x cosine x. So this clearly isn't just a straightforward antiderivative. We're going to need some kind of technique. So the first question we ask is it undoing the chain rule? Is it undoing the chain rule? Okay, no. So could you think of one small adjustment that you could make to this integral so that it would be undoing the chain rule? Everyone think about that. What one small adjustment could you make to that integral so that it would be undoing the chain rule like we did yesterday, Wednesday for homework? Got my list. Where is King? What little adjustment?
Is undoing the chain rule or is undoing the product rule?
No, undoing the chain rule is the one like what we did all day Wednesday. And like,
Remove the x.
remove the x?
For cosine x.
Remove it? Yeah, so if we remove the x or the cosine x, then we just have a really easy integral, right? So it wouldn't. So what's just something we can do without removing one of them? What's something we can do to make it? Where's Andrew Neiman? Is Andrew Neiman?
Yeah.
Tell me. Not sure. Okay. How about Ryan Dykus?
Could we make the cosine x squared?
He wants cosine of x squared. Let's take a look. So cosine of quantity x squared. Now would it be undoing the chain rule? Yes. This would be like g prime of f. And look, so then here's our essentially f prime, right? So what would our first attempt be? Our first attempt would be sine of x squared. Sine of x squared would be the first attempt as the antiderivative. Yeah?
Is there a reason you can't just treat it as cosine of x exponent 1 and then still undo the chain rule, or does the same rule not apply?
So the way I had it before, you mean?
Yeah, still
The original
use
problem?
cosine of x, but just treat the exponent as 1 and then still use that.
Doesn't work because the chain rule is of this form, right? G prime f of x times what? F prime of x. So the key is that the other term is essentially the derivative of what's the interior function. So the interior function here is just x. Its derivative is 1, not 4x. So this would need to be x squared so that its derivative is here as x. Does that make sense? So this was cosine x squared. We could do undoing the chain rule. But it's not. Okay, so here's where we're going to think of. We're going to think of this given integral as this, f g prime. And so what we need to do is figure out what f and g are, and f prime, and then solve the rest of it. So that means we have a choice. We can write down, so if we write down here f equals g prime equals, so either f's going to be 4x or f's going to be cosine x. And g prime is going to be the other one, whatever we don't choose. So let's just start with the order that's given. So we'll say f is 4x, g prime is cosine x. And so then what do we need? We're going to need f prime eventually, right? And we're going to need g. So what is f prime? Derivative of 4x. 4. And what is, so this is g prime. What is g? So that's the antiderivative, right? Sine x. So then we investigate and we say, is g f prime, is that a more attainable integral? That should be an easy antiderivative, g f prime, or 4 times sine x. Is that pretty easy? It is. So we made the right choice here with what we picked for f and g prime. So if we call this answer A, so say this is A, right? That's our answer. Then really what we need to do is we need to solve the integral g sine x times f prime is 4 dx. And what's f times g? 4x sine x. And so then what does A equal? So then our answer, I'm calling capital A, equals 4x sine x minus. Okay, and so then that is 4x sine x. Easy antiderivative here. So antiderivative of minus 4 sine x. Is that plus 4 cosine x? And then since this is indefinite, we're talking about all possible antiderivatives. Therefore, we need plus c. How can we check it? Yeah, does that make a mistake? Something wrong here? Something's not right. Where did I make a mistake? Antiderivative sign.
That should be like
Because the derivative of this is not this. So I made a mistake somewhere. Some sign error here. Help me, anyone?
Did you even write 4 sine x twice on both sides above a little bit?
Gx f prime f times g 4x. You see my error? Because I don't think.
G is negative sine x.
Yeah, your g prime under A is supposed to be a g prime, so g prime under A should be cosine x, shouldn't it, not sine x?
Yeah, 4x sine x, which 4x.
That's this. That's this. I'm solving for a. So I'm doing this minus this. Antiderivative of negative sine x is positive cosine, right? What's wrong with this? Because the derivative would be 4x cosine x plus 4 sine x plus 4 cosine x does not equal that. It's supposed to subtract off.
Let's write the product over the first derivative. 4 sine x plus
4 sine x,
4x cosine x
4x cosine x.
minus 4 sine x.
Oh, right. Did you take the derivative of that?
Fridays.
Every day. So it was right. I was doing the derivative in my head wrong. Okay, so we did it correctly. This is right. Take the derivative, and you get 4x cosine x, which is what we said. Okay, so questions on solving that problem?
Wait, why did you subtract the 4 sine x?
Because I'm taking the derivative to check the answer. The derivative of cosine is minus sine.
Oh, okay.
You see? That's the same thing that I did. I said it was going to be positive. Okay, next example. Or any questions on that? Okay, so next one. E to the 3x times x squared. Oh, let me just make a note of something from that last one. What was it again? 4x cosine x. In terms of choosing, we chose f to be 4x and g prime to be cosine x. And what happened? When we took f prime, it reduced the power of the x by 1, so we just had 4. So we ended up with a similar integral, but with the power of x being 1 less. Do you see that? So it was doable. 4 times sine x rather than 4x times either sine or cosine. So that's helpful in seeing how you should pick f and g prime. By picking f to be the x term, its degree goes down by 1 and makes this a doable thing, right? So 4 times sine x rather than 4x times cosine x. So that kind of helps you in making that choice of which one's going to be f and which one's going to be g prime. Okay, so next example. E to the 3x times x squared. Okay, let's practice. This is not undoing the chain rule. So what would be one small change you could make? Keeping both factors. What's one small change you can make to one of the factors so that it would be undoing the chain rule? He's got it. Anyone else think they got it? What do you think? 3x squared. 3x squared? This one? You want to put a 3 in there? Okay, but the real issue is the powers, right? So what power do we need on here to make it work? 3. If we had 3x cubed times x squared, then that'd be undoing the chain rule, right? Because you got that x squared is essentially the derivative of the interior function 3x cubed. Okay, but it's not what we have, so we try something new. Let's try undoing the product rule. So we need to determine what is f and what is g prime. So remember what happened last time. By choosing f to be our power, our thing with x, then that f prime has 1 degree lower, and that is simpler, right? That helps it be simpler. So let's try that same thing again. F is x squared, and g prime is e to the 3x. That means f prime is 2x, and g is, this is antiderivative, right? If this is the derivative, the antiderivative would be e to the 3x, but then you'd need 1/3, right? Antiderivative there to get g. So then we take a look. Did that help our cause? So again, I'll call the answer A here. What would f times g be? X squared would be 1/3 e to the 3x x squared equals A plus, here's our new supposedly easier integral, right? 1/3 e to the 3x times 2x dx. How'd that turn out for us? Is that an easy, straightforward antiderivative? It's not, because I got e to the 3x and then times 2x. Is it progress? Is it better than what we started with? It seems, I mean, it's kind of like we're in the same boat we had before. It's kind of similar, but it's now what? That instead of x squared, we just have x to the first. So what can we do? Yeah, so now we're going to take that one, and we're going to think of this, isolate this integral, and think of it as its own problem, which is going to be undoing the product rule. Okay, so I'll do a different color. That will help. So we're going to take this one here. And if we did it one more time, what would happen? That x to the first would be, then x would be gone, right? And then we just have integral of e to the something, and then we can do that. So we're kind of an iteration, right? So we're going to use undoing the product rule twice. So the supposedly easier integral became another undoing the product rule problem. But we should only need to do it one more time, and we'll have it. Okay, so then for the red one, so I use capital F and G, capital F's and G's. So for the red one then, so I'll do capital F and G prime. And so what should capital F be? 2x, right? So that F prime is 2. That's what we want. Get rid of all the x's. G prime is 1/3 e to the 3x. So now we need the antiderivative of that. Give me 1/9. We're going to need another factor of 1/3, right? So it's going to be 1/9 e to the 3x will be the antiderivative of that. And so now I'm going to call this one, I'll call this capital B. So what do I have? I'm going to have big F, big G will equal B plus my easier integral, which will be capital G f prime, right? So I'm just doing the technique again here on when I'm focusing on this red integral, which I'm calling B. Okay, so what is B? So capital F times G is 2x times 1/9 e to the 3x equals B plus integral of 1/9 e to the 3x times 2. Okay, so now we just got to carefully move all the symbols around. Do one more easy antiderivative. Carefully get the symbols in the right place to solve. And what are we after? We're after A. We're after solving for capital A. So B is 2/9 x e to the 3x minus antiderivative. So we've got this e to the 3x, which is the antiderivative, is going to need another 1/3, right? So I have 2/9. We need another 1/3, so it'll be 2/27. If I lose you, please ask me if I lost you. Yeah.
Since you have FG on the left side,
Mhm.
did you just substitute it for? The reason I don't get it is why you subtracted by A instead of subtracting by B.
I'm working on integral B right now.
Yeah, that's right.
So B equals this minus this. That's what I just did. B equals this minus this.
Oh, okay. Okay, yeah, never mind.
So this is this thing minus the antiderivative there.
Okay, yeah.
You with me now?
Yeah.
So 2/27.
So 2/9. But now when I do antiderivative of e to the 3x, I need another 1/3.
Okay.
So 2/9 and then is 2/27. Okay, so now we can write down A, what A is. Now we're back to A here. So A is going to equal, here we go, answer. This minus our solution to B, right? So it's going to be 1/3 e to the 3x times x squared minus this, 2/9 x e to the 3x minus 2/27 e to the 3x. And notice my answer has a x to the 0 term, it has a x to the first term, and it has an x squared term, all with e to the 3x's. Since this is an indefinite integral, again, we want all antiderivatives, so we can just add that c just at the very end, right? We don't need to add c's along the way. Right? Every time we do an antiderivative, we just add one c at the very end. Okay, ask me if I lost you. Yes, please.
The only thing I'm clear about is why we're solving for A. Why are we solving for
That was the original problem. So that was this right here. So A was this integral right here.
okay. Gotcha.
And then that was equal to, this equals A plus this one, which we did as a separate problem, and came back and, I don't know, do you see it now? You're good. Okay. Good. I was running out of words there. Any questions on this one? So how about, e to the 5x times x to the 10th? What would that be like? We'd have to do it 10 times, right? We'd have to, you're not required to do that, but just want to get you thinking about that. So e to 3x times x to the 10th. So it was take 10 iterations of this, and you would surely get lost and never do it right.
So if you have, if you don't have x to some number, can you not use the product rule?
Yeah, so let me talk about common forms. Let's talk about common forms for when you're looking for undoing the product rule. Last chance to ask about this one. Okay, so common forms. So the two we did are kind of the most common, all right? Some power of x times sine x or cosine x. That could be cosine x. Some power of x. And then you can also have, to me more general here, so sine, say, kx. And we can handle factors, that's no problem, right? So k is any real factor, coefficient of x. So x to the n sine of kx, right? Well, like we just saw, x to the n e to the, say, kx. All right, so now natural log and also like x to the n, natural log. So there are many, there is undoing the chain rule that involves natural log of x, but there is also, if you have a form like this, just plain old natural log, or x to the n natural log of x, that is undoing the product rule. So let's actually practice that. So let's do, why don't you do x to the 10th ln of x. Yeah.
That first one, what are we saying there with the common forms? You got a sine and a cosine. I missed your explanation of the first.
Just x to the n times sine or x to the n times cosine.
Some trig function or sine or cosine.
Sine or cosine.
Sine or cosine.
Sine or cosine only. And then I was just making a general argument there, like a constant times x. All right, so I want you to try x to the 10th ln of x. See if you can do that one by undoing the product rule. So this one's a little different. It's a little different. So I'm guessing most of you will have started this way, and you're going to come to this right here. Here lies in the problem. Okay, so what is the antiderivative of natural log of x? Well, I just told you that requires undoing the product rule to figure it out. So what does that mean? It means we need to try this a different way. What did I just do? So how else could we get started on this one?
Just flip them for F.
Right. So we can't make g prime natural log of x because we don't know what its antiderivative is to get g. That's the point. So
Value actually just undefined. Like nobody
what's it?
So what's the derivative of natural log of it?
No, it's you can do it by undoing the product rule. Yeah. Okay, so we have homework on this over the weekend. We got to get it. So, how's it coming? Don't wait for me to do it. You gotta show me what your F and G prime is. Okay, good. 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 Right. Start. Okay. Okay, so most of you correctly said that instead we need f to be natural log in this case, and g prime to be x to the 10. Where's Don Tram? Don. Tell me about f prime and g. Did you get those? What's f prime? 1 over x, and g is? All right, and so then what we're going to do from here is, so what integral are we going to solve there? So our alternative integral then for this one, where's Isaiah? Isaiah Haynes? Yeah. So what is going to be our integral g f prime? So if our g is this and our f prime is this, then what is the integral that we need to do? How about Zhao, Zin? Last name Zin? How about Boris? Boris, over here? You're not sure? So we just got to get the symbols in the right place. We got all the right things. We just got to substitute correctly. Yes, sir. 1/11th. So let's just write it all out explicitly. 1/11th x to the 11 times 1 over x. All right. So we're just filling in the blanks here. What is g? It's this. What's f prime? That's this. And then over here, f times g. ln x times. So then we get a equals 1/11th ln x times x to the 11th minus 1/11th, like you said, 1/11th x to the 10th. Integral 1/11th x to the 10th. Do we have to do it 10 times? No, so these natural log, x to the n natural log of x, the exponent of x can be anything, and it only requires one pass at it. What's that? So we got 1/11th ln x, x to the 11th minus x to the 11th times 1 over, we need another, yeah, so we need another 1/11th, right? Yeah, so 121 plus c.
How do you do it if it's just natural log?
So if it's just natural log x, then one of these is going to be natural log and one of them is going to be 1. So which one's going to be natural log and which one's going to be 1?
Basically, the third common form was just ln of x.
Right. So I'm asking you, how are you going to do it? So when it's just natural log of x, then one of these two is going to be natural log and one of them is going to be 1.
Oh, 1?
1 times, you think of it as 1 times natural log. Right, so when you do the antiderivative of just natural log, you're going to think of it as 1 times natural log. You have to decide where's the 1 going to go and where's the natural log going to go. It's the same problem we just had, right? Okay, listen up.
Wait, never mind.
Before you, so I'll stick around and talk about this, but for Monday, you're going to have the continuation of the undoing the chain rule on the WebWorks. Hopefully you jumped in and started working on the WebWork. Then I'm going to open another WebWork set of these problems. So you're going to have 2 different WebWork sets due Monday. And it'll be, that's why I told you to get started on the last one. So that'll be due 1:15 on Monday, 1 p.m. Monday, half an hour before class, 1 p.m. Monday. Okay? You can use that email instructor button. At the bottom of every problem page, there's an email instructor button. You can use that, but just give me some description of your difficulty. Be specific. Good.
Okay, well, I got a little bit confused by what A is supposed to mean and
The answer.
the answer.
Would I put a box around?
Okay.
So just rather than rewriting that, I'm just saying A is the answer to the original problem.
So on
Hello, where am I?
Josh's poll,
Oh, I unplugged.
I already did the poll.
yeah, I'm gonna close that on Monday, and then I'll.
Okay.
So this is A,
If you could send me,
right?
I guess a picture of it.
Yeah. I'll-
Because it's that.
Oh, so you pretty much just.
If you wouldn't mind, email me.
Yeah, I will.
Rather than keep rewriting this over and over again, or rewrite this over and over again, I just call it capital A. So that is what we're trying to find. So then we set this up so that we find the easier antiderivative, and we find f times g, and then what will A equal then? What will ours equal? That minus that.
Okay. Well, can you make his up?
Okay, and is the one all the way to the far left just formulated from the different pieces you get?
What are you looking at? What?
The very part at the left. So
Here?
ln x.
Yeah, it's this minus this.
Okay.
It's just algebraically we're solving for A, right? Algebraically solving for this thing, which will be this minus this.
Okay. And how do you choose which of the 2 parts at the beginning is going to be f and which part is g?
So that just depends on your situation. If it was, we had like x or x squared times sine x or e to the x or something like that. Then we want f to be this, because every time we take the derivative, it'll go down 1 power. Remember that?
Yeah.
So every time it goes down 1 power, it becomes closer to just going away. And once it goes away, then we got an easy, either easy sine x or easy e to the x. But then we discovered on this one, that doesn't work, because if you have natural log x here, we don't know what the antiderivative of that is. That in itself requires undoing the product rule. If you have the antiderivative of natural log of x, you need undoing the product rule to figure that out. So that's not going to work. So then we switched it. So it's like you try one, and if it doesn't work, then switch it.
Okay.
So since natural log can't be there, then we put it there and put x to the 10th there, and then we just see if it works.
Yeah.
And it works. So this one worked out.
Can you explain to me why it works? Like, I know how to do it. I know what you're doing. I just don't know why does that give you that derivative? Like, I know that it gives you it, but why? Like, how does it?
Which part? What are you talking about? So here's the.
Solving for a give you that derivative. Like, I know it does.
Because if c equals a plus b,
Yeah, I know that.
then
Yeah,
a
I know
equals
that.
c minus
Yeah,
b.
yeah. I understand that.
This is the product rule.
Yeah.
The derivative of f times g is that plus that. This is the product rule. So then I'm just taking the antiderivative of all 3 terms of the product rule. That goes back to the previous slide. Can I erase what's on the screen? Are you good with what's on the screen? Can I erase it? I mean this problem, this one about the natural log. Can I get rid of that? So this is the product rule, right?
Yeah.
So I can maintain the equality by taking antiderivative of everything, right? So here I'm taking the antiderivative of the left, and the antiderivative of that, and the antiderivative of that.
Okay.
So
Yeah,
this is really
yeah.
just the product rule in a disguised form.
I get it now.
So now we'll be given a problem like this, where it's like the antiderivative of one of the terms that you got when you did the product rule.
So it's the original one. It's the rate of change that we were given at the beginning.
No, this is what you'll be given. You'll be asked to solve an integral. If it's undoing the product rule, then what that is that rate function is really one of the two terms that came from the product rule. So it's kind of like here. If I had what's the derivative of sine x times 5x? What's the derivative of that?
Cosine x times 5 and then 5x times sine x. I mean 5x times
Cosine x times 5x plus
Sine x times 5.
sine x times 5. You see that? So that's like someone came along and said, what's the antiderivative of cosine x times 5x? How would you find that out? How would you figure that out? Well, I can use this. I'm using that cosine x 5x is one of the terms in the product rule to do it. So to solve that, I'm using the fact that when I do the product rule of sine x times 5x, I get that as one of my terms. And now they're asking me to do the antiderivative of that. So what would it be? So I want to do, if I want antiderivative of that. So now that's the problem I'm given. Well, it's going to be, well, this is just sine x 5x. Right? Minus that antiderivative will give me that antiderivative. So that's what we're doing.
I need to digest that. Like I know how we're doing it, I just still can't get it wrap my hand around.
Where do I lose you?
Conceptually.
So you understand the product rule, right?
Yeah.
So this statement is like the product rule, but it's the antiderivative of each term.
I understand that.
So a problem that we're given to solve could be something like what I've highlighted in red here.
Yeah.
So I'm going to give you a problem. I'm going to say, hey, find the antiderivative of 2x e to the 4x. What you recognize is, oh, that is like that.
I just figured it out. I get it now. So you have to take the antiderivatives of all three of them. That way you can make them equal and then solve it that way, because you couldn't do it the other way, right? There's no way you can solve it. There's no way you can solve it if you just had it as the top part. Like if you just had f of g equals. Wait,
Remind me to turn the volume down in here. That buzzing is terrible.
Oh, wow.
I forgot today. I usually do it. I just totally forgot today. I didn't get my attention. So you can remind me.
Yeah.
It's much better, isn't it?
I just thought that was the building.
No, that's the sound system. Yeah. See, here's the thing. When you're given a problem that's of this type, you're not given this. You're not given the antiderivative of that. You'd just be given the antiderivative of one of the two. Right? So the problem that you come across is going to look like this. Where the thing we're taking the antiderivative is one of the two terms, the sum of the two terms that you get when you do the product rule.
It's a trick.
Yeah, I know that, but I'm trying to. So I know how to do it. I'm just trying to figure out like why it works. Does that make sense?
Well, do you believe this statement right here?
Yeah.
So do you believe
yes.
the truth of this statement?
Yeah,
And do you
that's
follow that?
Yes, I follow.
So then what we're saying is that's going to equal fg minus g f prime dx. So if you believe the truth of that statement, then it's just one easy step of algebra. You're just going to subtract this from both sides.
Yeah,
You see?
Yeah.
So then we're going to look at that and figure out what f and g are, and figure out what f prime is, and that expression is going to be equal to the one we were trying to find.
Is that the only way you can possibly find that expression?
What?
Is that the only way you can possibly solve that antiderivative? By
It depends on which antiderivative. So some antiderivatives can be solved by more than one technique. But if you have a basic form of this, like x sine x, this is by far going to be the easiest way to do it. There may be another technique that will do it. I don't know. But when you have the basic forms of undoing the product rule is going to be the most efficient and possibly only way to do it.
okay, I think I understand it.